One of the things that I really like to do is to use field observations, and sometimes that's aerial drone data, sometimes it's even underwater drone data as well, or snorkel data, to look at mapping the density of different features on the reef. And this could also be transported to thinking about how we map the density of features on land as well. So it could be coral cover or it could be tree cover. And so we can do this in high spatial resolution imagery like drones or field survey data, and then use that to train models with satellite data that give us quantitative assessments. So instead of going for the standard categorization of something in a satellite image, like a land cover classification or a habitat classification on the reef, we actually start to get density assessments of our different features. We can think about what is the density of seagrass within each satellite image pixel, as opposed to it's seagrass or it's not seagrass. So we can get so much more information when we combine those two data types together to give us a lot more information about what's going on in the ecosystem. And then it's also a lot more sensitive to minor environmental changes as well. So where you might get a decline, let's say 10% in seagrass or tree cover, whatever that variable is that you're looking at, you may not actually be able to tell that categorically there's a difference in it being seagrass or it being a tree, but you can actually get from the satellite data that the density has declined. So by combining both those data sets, it makes it really powerful. I think that one of the biggest challenges that we have on a day-to-day basis is the sheer volume of data that we have in our lives. So for us, as geospatial and Earth observation data, there's so much of it. We capture petabytes of data every single year looking at Earth. And for me, when I think about drone data, that's the stuff that I capture for myself as opposed to what satellites are capturing globally. And one of the reasons that we started GeoNadir was this feeling of data toxicity, where there's just so much of it and we don't necessarily know what to do with it. And what we've done with GeoNadir is to create a platform that actually makes it easy to find. And so instead of sifting through folders on a hard drive or on a server and not being able to visualize where those data are located or what they look like, we've really pulled that out and made data much more visible, which means that when you're aware of where it is, what you've captured and what it looks like, you're much more likely to then be able to use it. And then when you can use it, that's when we start getting the information out of it. So it's no longer just this feeling of overwhelm, having data coming out of your ears, but it makes it manageable and it actually really makes it a lot simpler. When we created GeoNadir, what we decided was that we wanted to provide a platform for people to be able to make their data sets findable, accessible, interoperable, and reusable or fair. Now, what this means is that people have the ability from all over the world to share their data with each other and with other people that they've never met before. Probably the most surprising thing for me when we started this is that people have just jumped on board and embraced it. The overwhelming majority of people are just really happy to see their data used for more than just what it was captured for in the first instance. And so to be able to do this has also helped me connect with people all over the world from all different countries with the work that they're doing and understand more about Earth from their perspective as well.